equivalences that I'm going to write down, you can prove it by using the truth table. So I'm not going to prove it, but still you can try to understand it just when I'm writing it down. So the first one is, we call it identity law. Identity. Identity means it doesn't change. Identity law. So there are two laws, okay? One is, you have a P, any proposition P, and if you n something that is always true, okay, then it is always going to be equal to 2. Is that okay? Does that make sense? Yeah, so, yeah, you go through your mind, okay? When P is true, then P and T is true. When P is false, P and T is false. So P and T always agree with the value of P. Okay? You have run the truth table in your mind already. Okay, but let me tell you something that I try to memorize it by myself. This AND operator is like similar to a multiply in mathematics. This OR operator is very similar, but not always the true, or like a plus. Okay, this true is very similar to a 1, and then this false is very similar to a 0. Okay, so something, if you multiply by 1, then it gets back to itself. Okay, so this is something that you may interpret. So similarly, we have an identity law that corresponds to OR. P or F is still equal to P. It's like something plus 0 is equal to itself. Okay? So the first one, identity law, done. Okay? Now the next one, okay, the next one here, we call it the domination law. Domination. So we have laws here, because one corresponds to the N, one corresponds to the O. What is meant by domination? What is meant by domination? In English, what is meant by domination? Domination means you control someone. You dominate someone. You are going to make yourself the boss. Okay, everyone has to listen to you. You dominate. Okay. So when is a proposition being dominated? So P and F. I have a P, but then I and F. So no matter what P it is, the value is going to be equal to F. Always, right? So it's like P doesn't have anything to say, but has become dominated. And similarly, if I have a proposition P, and then I have OR is true, then it will become true. And it is now dominated by true. Okay? Is that okay? So anything plus 1 turns out to be at least 1. So at least 1 maybe we are saying that it is equal to true. Okay? Looks like that. Okay? And then the third one is a strange word. Idempotence law. This word, I need to check this one, I forget. So potence, it means something like your value, so equal value. Yeah, it looks like identity. Potence, your potential, your value of yourself. So what does it mean? It means that it means okay to apply many times. So you will see what it means soon. So for instance, P and P. So P and P. I have a P, and then I have and P. So P and P, you can simplify it as just P. Okay. Does that make sense? If P is true, then P and P is true. If P is false, P and P is false. So it agrees with P. Similarly, we have P or P. It's also So no matter you apply the operator many times on yourself, then you still get the same value as yourself. Okay, so this is called idempotent laws. Okay, so there's no need, actually to memorize the spelling of this word. So in the exam, we will really ask you about this, but then we'll give you a table, a list of the laws that you can apply. And then why we are going to do so? Because the most important thing is you will later apply this law to prove equivalence. It's not always very convenient. We have seen that. It's not always convenient to draw a truth table to prove equivalence, because when there are many variables, then you get into trouble. Instead, we can use these laws we are going to talk about to simplify the statement. So we will have an example here. And then in that case, you need to memorize some laws that you can use. And then that memorized part, we will give you a list. So it includes all the laws, the names, and then when you apply it, you say that, okay, you are applying what kind of law here in this simplification step. Okay? Okay, we'll see. Okay, so these are 3 laws so far. Okay, the next one is very important. It is called De Morgan's law. So it is from this mathematician De Morgan's law. Okay, so we have seen one of it, not P and Q. So when P and Q is not it, then it will be equal to not P or not Q. Now, so I've actually omitted the bracket here, so I should write the bracket here. But sometimes we can save our writing a little bit. Okay. There are some conventions that we can follow. Okay. So this negation is like minus symbol. So it's like 1 plus minus 3 is equal to minus 2. Is it okay? Okay. So this minus is always attached to the variable closest to it, to the proposition closest to it. So if this is the case, then I can just ignore this bracket, because I know that this negation is going to apply to this Q only, this single Q only. So I can remove this so that the formula, the proposition looks cleaner. Okay. And similarly, I can remove this. Okay. But I cannot remove this. If I remove this, what will happen? It will mean not P, this particular thing, and another thing Q, rather than not bracket P and Q. Is that okay? So here, when in doubt, when we are not certain, then you add bracket. So when you are very certain, when you are certain that our tutor can understand what you are writing, then you can omit this bracket. Okay. So in computer science or in programming, this is called precedence of operator. So we have a lot of operator that we are applying on the variables. Which one should be applied first? Which one should be applied later? Which one should precede the other? Precede means before. Okay. So which one should precede the other? So this is about the precedence rules or the precedence. So here, the one that has the highest precedence that we should always do that first is this not. And then the next one, the next level is and or. Okay, these two will have higher precedence than the other. And then the next level is something like this, or maybe exclusive or like. The next level is this imply and this. Is that okay? So this is the convention. Okay, similar in mathematics, we have also precedence. So the most famous precedence is you should do what? Apply or division before you do addition or subtraction. Right? In Chinese, it is very good. 是先乘除后加减。Okay, so very good. Yes, very good. Okay, so this like the plus or minus should have the lowest one, the lowest precedence, and then higher than it, it is the multiply or the division, right? But when you have multiply or division, then probably it is going to be left to right. So we have a multiply, we have a division, we have many of them. The one on the left should be applied first, then the one on the right. Okay, so somehow the precedence can be among different kind of operators, or even if a certain kind of operator, if we have operators of the same level, then we still need to specify whether the left-hand side should be applied first or the right-hand side should be applied. Okay? And then there is one even higher than the multiply or division, the index, okay, the power. It's like, you see something like 2 to the power 3 times 4. Okay, maybe something like this, you are going to write it like in a textbook. It's like 2 to the power 3 times 4. Now you actually mean that this power should be applied first, rather than you are trying to do this 3 times 4 first, and then make a power. Okay, so even in mathematics, there are different kinds of operators, and then there are different levels of precedence. Okay, so okay, that's it. Okay, now this is the De Morgan's law. De Morgan's law is always used for negating some proposition. So if I have proposition P and Q, then I want to negate it to get a not. Then I can use this to simplify it into some simpler one. You remove a bracket here, right? So it becomes not P or not Q. So we've proven this there somewhere, perhaps. And then similarly, yes, this one is not P or Q. It is going to be equal to not P and not Q. Okay. So De Morgan's law is very easily memorized. If you know something, you change each one to the negated part. You change and into or into and. That's it. Okay. Okay, so it's like an upside down law. You make everything inverted. From positive to negative, from negative to positive, from and to or, from or to and. Okay. So, okay. And then again, how do we prove this? We can use the truth table to prove it, because there are just 2 variables. So the truth table, we just have 4 rows, so it will be simple. Okay, another one is this one. This is the commutative law. So commutative law means we can exchange the ordering. So P and Q, we can exchange the ordering as Q and they will have the same truth value all the time. Okay. Similarly, we have P or Q. It's going to be Q or okay. So this okay, the next one. Next one is associative law. So all this law also happens to appear in your algebra course or in arithmetic course, like that. Plus 5 plus 3 is equal to 3 plus 5. 5 times 4 is equal to 4 times 5. Okay, commutative law. So associative law is this one. So associative law, we have 3 things: P and Q and R is equal to or equivalent to. You apply P and Q first. Okay. So you can move the bracket, do whatever. As long as they are all the same symbol, and. You have a bunch of and. You can do whichever and first. And similarly, you have P or Q or R. So this one is the same as you first do P or Q, and then you do OR. So this is associative law. Associative law works for the plus or the multiply, but it doesn't work for minus. So we have seen that. 5 minus 2 minus 3. You should do the 5 minus 2 first, and then minus 3. You cannot do 2 minus 3 first, and then 5 minus resulting later. Okay, so in arithmetic, plus or multiply follow this associative law. They are associative. These operators are associative. And here, and or, both of them are associative. Okay, now this is a new one, but you will see this is perhaps the first one that is not that trivial. This is called distributive law. Okay, distributive law. And 5 times 1 plus 4 is equal to what? Okay, 5 times 1 plus 4. Oh, of course you know it is 25. Okay, but then, of course, you can also do 1 plus 4 first, so it is equal to 5 times 5. But what I want is, it can be written as 5 times 1 plus 5 times 4. Is it okay? So it is like this 5 can be distributed, okay, into this one. You do an operation, and then here, this one. So you distribute this 5 to each of the item inside. You do the operator, multiply first, and then you add them later. Okay? Now, it's very nice. We have seen that and or it is like add and multiply. So it actually works. So if I have something like P and Q or R, okay, now this will be equivalent to, you do P and Q, you get a value. You do P and R, you get a value, and then you OR. Okay, interesting, right? Right? But then, the most interesting part is not this. Okay, you believe this is true because and looks like a multiply, or looks like an and. What is not trivial is you can do the exchange. Okay, P or Q and R. It turns out that it is really equal to, you distribute this P into each of the term, P or Q, P or R, and then you add together. Wow, this is something that is not trivial. So for instance, you have something like 5 plus 1 times 4. You don't write it as 5 plus 1, and then 5 plus 4, and then you multiply them together, you multiply them together. It doesn't look like this. It is not true. It is not true. But in logic, in this true-false thing, it turns out that it is true. True. How do we prove that? We use the truth table to prove it. Okay? Yeah, this is really, really strange. But then, so this is the distributive law for these and or operators. Okay? So it works not just and or, it also works for or and. Okay, you can distribute this thing inside. Okay? And then how you memorize it? Yeah, we should still memorize it using this one. Because otherwise, you don't know whether we should fill in an or here or and here. Whether we should fill in an or here or and here. If you memorize this one, then you know that, okay, this is P something this, P something that, and then we or together. Is that okay? Good. There are 2 more. One is this absorption law. How come? I missed one of them. Oh, there's double negation. I forget. Okay, so let's do double negation. Double negation law is just one law. Okay. Not of not P is equal to what? P per P. You do one thing 2 times not, then it gets back to itself. Okay, and then we have another thing. We call it negation law. Negation laws. Okay. So negation law is P together with not P. P and not P, you will get false. Okay. And then P or not P, you will get true. That's it. So these are negation laws. Okay, there is one last one. Okay, the 10th one. It's called the absorption law. So absorption law means that someone is being absorbed. It's gone. It's like there's a big pack. And then absorb something. Or I don't know. Anyone has watched Dragon Ball? The comic Dragon. Yeah, I'm too old. I saw only one head. 龙珠. Oh, okay, too old now. So Dragon Ball, there's a famous character, Cell. Absorb someone, right? Cell,绿绿的那个 Cell， 有人知道吸入吗？啊，有，太好了。Okay, so there's one. Okay, cell. What is a cell? Okay, cell is 细胞嘛. Okay, so cell. So there is a character, a bad guy. Okay, called cell. He can absorb anything, and then into itself. Okay, so this is absorb. Okay, and then okay, so what is absorption law? Okay, so this is really strange. I seldom use them, but let's write it down. So let's guess. So this is P and P or Q. Okay. Is what? P and P or Q. Yeah, so of course we know we can use this distributive law. So using this distributive law, then this will become what? This will become P and P, right? And then or P and Q, right? Is that? And then using what? This idempotent law, this P and P, you can further simplify. It is just like P, it's one thing only, or P and Q, right? Right? Now look at it. If P is true, then this is or. Then you get a true already. If P is true, then this will be true. Because this part is true. True or something is true. Now if P is false, what will happen? If P is false, this side is false. And then this this little part is also false. False or false is still false. So what does it mean? It means that Q doesn't matter. We didn't actually discuss what is the value of Q. Q is gone. It is absorbed. Okay. So P and P or Q. Okay. It turns out that it is P. Okay. And similarly, we have P or P and Q. Okay, this one is also equal to P. Okay. Yeah, how do we get this? Of course, we can do the argument again. But let us try to prove this using this one. So what are so special about this and this? This is like or becomes and becomes or, right? Okay. So let's do this. So let's try. Okay, let's try to use some. We don't know whether this is true or false. But let us try to prove that this is correct using some very strange way. Okay. So first of all, we want to know what is P or P and Q. Okay. So we hope that after certain steps we get a P in the end, because we want to show that they are different. P or P and Q. Okay, so this is equivalent to what? We have this one double negation. So I'm trying to use double negation. So this one is equal to what? Not P or P and Q. Is that okay? Because this is the original one. Original one must be the same as the not of it. Okay? And now, here, this is not of a bunch of things, right? So this is a good time to use De Morgan's law. When you are not something, then yeah, De Morgan. Okay. So not of this one, so it will become what? So I'm going to write it here. So it will be going to be a long one. So it's not that difficult. It's going to be not P. Is that okay? And or becomes N. And then this one is simply not of this one. Is that okay? That's it. So I add a bracket here to make sure that so far, if you're okay with this, could you please raise your hand? Okay, so here, then what do we have? Yeah. So we want to apply this one here actually. Okay, so we still okay. Thanks. So we still make this bracket go. Okay, so this is equivalent to the knot of the yellow part. Okay. This yellow part is not P, and then still an N, right? And then the inside it is De Morgan's law again. Not P or not Q. Very good. So this is not P or not Q. Okay. So is that okay? So far so good, right? Okay, thank you. So this is equal to what? Okay, now suddenly you can see that it is in the same format as this one. This is something and something or something, right? Okay, what is that something? The something is just not P here. So this is equal to, so the not here, so the yellow part here is going to be just simply not P. Is that okay? Here, this apply the absorption law 1. Okay, done. Okay, so this is not of not P, and then this is equal to 2. Is that okay? Good, okay. So sometimes what? So this tells us what? This tells us that when there are just two variables, we should always use the truth table. Understand? Yeah, truth table. It's just 4 rows, and then you should not get into a big trouble. Okay. So sorry for overrunning the first class. So let's take a break, a 10-minute break now, and then we come back, and then we will see some more examples, and then we will talk about logic puzzles again. Okay.